Hi students, let's look at this concept here, this new concept called the chain rule. This is actually quite an important rule, the rule which we use quite frequently in the topic of differentiation. Let's see how, what does it mean? So basically, if you're given a composite function, what chain rule says that actually you can write dy dx is equals to dy du multiplied with du dx. So it could be any form, like it could also be dy. Basically what it's trying to say is you can just put a dx here and dy here. You can just put anything. So that dA, now these are all variables, so you can be dv here. Okay, so this is actually chain rule, and it's very common, right? So why? So for example, we have already explored how to differentiate, like for example, y equals to x squared plus 1 squared. Now what you will do is essentially, without using chain rule, you will just expand it, right? And this will be x4 plus 2x squared plus 1y. And basically this will give us 4x cubed plus 4x plus 0. Okay, but the problem now is if this is the power of 10, you are not going to expand it like 10 times, right? It'll take forever. So what you need to employ is actually using chain rule. Okay, what chain rule does is you could just let the variable be x squared plus 1. So in other words, just let u equals to x squared plus 1. So what we're going to do is actually we're going to convert y in terms of u. So this is u to the power of 10, right? And yeah, then that will be quite cool, man. So what you're going to do is actually you just write this will be du dx will just be 2x, right? You differentiate u with respect to x, and this will be dy du, which is actually 10 to the power of u9. Okay, u to the power 9. So once you get that ready, what you could do is actually just put dy dx is actually equals to dy times something dx, and basically just, I like to write it in this way because it tells you, like, you know, it shows you how things work. So this can be 1, right? But in this case here, what I'm going to do is I'm going to put du and du, okay? And basically, once you're done with this could be dy du, which is 10 u9 times du dx, which is actually 2x, okay? So this will be 20x u to the power 9. But just bear in mind, because u is something you introduce into the equation and not something which was given in the question. So what we're going to do is actually, we're going to substitute it back in. So 2x to the power of x squared plus 1. X squared plus 1 to the power 9. Okay, so we just replace our u with this expression here. So done. This is my dy dx. So, now, do you always need to let u be that expression there? Actually, no. There's actually a faster way to do it instead. So the faster way to do it would be, I always call it the onion layers method. Would be, you let y equals to x squared plus 1 to the power of 10. All right. So what we're going to do is actually just layer it out as such. So this is like a whole big thing, big chunk outside, and just layer this inside one. We're going to write dy dx, and basically just see this whole thing as an entity. All right. So when you differentiate this outer layer, it will be 10 x squared plus 1, 10 minus 1, which is 9. Okay. And then after which you differentiate the one inside, which is actually x squared. So this is 2x. So this will be a faster way. So you layer it out as such, this outer layer and this inner layer. So this is chain rule. Don't worry if you get confused. Let's just try the subsequent questions, and just keep practicing. And if any questions, just let us know, and keep practicing, right? I'll see you in the next question.